Hello and welcome back to Cybersecurity. We are super excited to get going with this lesson, so let's get started. In this session, we'll examine the different infrastructure options for businesses more closely. A network infrastructure enables connection and communication, each of which are critical to the success of any business. Simply put, without a sound network infrastructure, IT components, including hardware and software, aren't much use. Making sure your network infrastructure is robust, secure, and clean, and that it satisfies your particular needs is critical to organizational excellence. So here we are in Lesson 6 of the Cybersecurity course. In this lesson, we'll be looking at the different types of network infrastructures available for businesses. Your subject matter expert for this course is Edwin Ode, and he has worked in the area of physical security and system administration in one of the best tech companies in the world. So he has a wealth of knowledge and experience to share. And you already know my voice. I'm Nina. In this lesson, we're going to explore the different infrastructure options and how they can be applied to an enterprise network. In doing this, we'll discuss the benefits of implementing a centralized or decentralized infrastructure. We'll describe the converged infrastructure and how it stores data within the network, and then examine how a converged infrastructure can be upgraded to become a hyper-converged infrastructure. Let's have a quick recap of our previous lesson. You will recall that we discussed the internet, intranet, and extranet and their respective benefits and differences. We also looked at how they can increase productivity in an enterprise network with the use of wireless network file sharing. And lastly, we looked at how encrypted information or traffic is sent over an extranet network. Before we dive into network infrastructures, let's quickly talk about deployment and virtualization, two terms that are commonly used in the context of network administration. Basically, deployment refers to the setting up of a new system to the point that it is ready for productive work in a live environment. In the simplest of terms, deployment is the startup or initialization of a task, which could include a piece of software, configuration, or even a pipeline of both simultaneously. When deploying a new system, big organizations often use virtualization. Basically, this means combining all their hardware and software network resources and functionality into a single, software-based administrative entity, a virtual network. By using virtualization, companies are able to implement redundancy without purchasing additional hardware. Redundancy, a third important term to get your head around when discussing network infrastructure. Network redundancy is the process of installing additional network devices, equipment, and communication mediums within a network infrastructure to ensure network availability and decrease the risk of failure along the critical data path. Now, when it comes to setting up an enterprise network, there are 5 different infrastructure options. They are centralized infrastructure, decentralized or distributed infrastructure, converged infrastructure, hyper-converged infrastructure, and cloud-based infrastructure. We're going to look at the first 4 in this lesson, and we'll have a closer look at cloud-based infrastructure in the next lesson, after a discussion about enterprise portals and policies. So let's look at our first type of network infrastructure, a centralized infrastructure. Basically, a centralized network infrastructure is where the whole architecture is built around a single server that handles the major processing such as the quality of service, or QoS, of all aspects of the network. All the users are connected to the central server via the powerful workstations that submit their requests rather than performing them directly. The centralized server retains total control over all aspects of the network, managing all the data and permissions. Did you know quality of service, QoS, mentioned just now, is a set of technologies that work on a network to guarantee its ability to dependably run high-priority applications and traffic under limited network capacity. To enable you to better understand a centralized infrastructure used on a remote site, we are going to look at a user story. The case study. A company is considering setting up a centralized infrastructure that will allow multiple applications or software to be shared across the USA, Asia, and Europe. The company has a specification in place to show the number of users that will be connecting to the network and the resources to be shared. It looks like this. Users. The system must be designed to support 1.5 million to 3 million users and 5,000 queries simultaneously. Resources. It'll comprise 1,000 hierarchical resources, each with multiple actions to be shared in communication between all connected users. Then latency, or the time it takes for data to get to its destination. It needs to allow for less than 0.2 seconds per query response time for role and rule-based decisions. In terms of infrastructure, it's one central enterprise covering all geographies. Here is a diagram of the company's potential centralized infrastructure. Our first stop is the policy enforcement points, PEPs, at the bottom. A policy enforcement point, PEP, is a component that serves as the guard to a digital resource on a network. If a user of the system tries to access a file or resource, the PEP component will associate the user's attributes to the policy decision point, PDP for short, component in the middle of the diagram to make decisions based on the user's attributes. PEPs are compatible with web servers, portals, legacy applications, LDAP directories, and SOAP engines. We'll talk more about PEPs when we get to the section on network security. The Entitlement Database, or DB, at the top of the diagram is a collection of information, typically aggregations of data records or files, resources, and other vital information about the company. If databases are your thing, you may want to check out our fantastic database development course, also available from Shaw Academy. To continue our discussion of our case study and a diagram of the company's centralized infrastructure. The administration of entitlement or entitlement management is generally monitored by a high-level administrator in the company. The company uses this to manage, identify, and access the lifecycle on a larger scale. The process is usually automated because of the large number of requests. The Policy Administration Point, or PAP cluster, comprises the components that enables the company administrator to create and edit digital policies on the network. The PAP can also be referred to as the Policy Management Authority, PMA, due to the fact it helps manage different policies in a network. The Hypertext Transfer Protocol, HTTP, refers to the medium of communication, in most cases through the use of organization portals. And then the Redundancy Management Interface, RMI, is used as a secondary link between the active and standby wireless controllers. The RMI manages the Hot Standby Router Protocol, HSRP, that is used to create virtual IP to ensure redundancy in the case of a network failure. So how does this all work together to satisfy the needs of our case study company? From our user story, we would have 3 remote sites in USA, Asia, and Europe, and the main centralized server running from New York. In New York, the centralized server is where we would have the Policy Administration Point cluster and the Policy Decision Point. This means that the New York system administrators will be able to create and edit digital policies. The system administrator will also be able to control who has access to file or resources on the company's network. All the traffic from connected users on the remote sites will have to go through the centralized server in New York. So what are some of the main benefits of centralized infrastructure? The most obvious reason for businesses to adopt a network infrastructure like a centralized one is to ensure the efficiency of the network. There are some benefits to go with a centralized infrastructure. reduced costs, for example. In a centralized architecture, the main server is carrying most of the workload, and therefore companies can spend more funds acquiring a very sophisticated and dedicated centralized server and less money on the interconnection between the small modules in the remote sites and centralized server. With this system, considerable money is saved across the various locations of the company. Then there's increased productivity. If more sophisticated and dedicated servers are operating as the centralized server, this will be where things like QoS mentioned earlier and other requests and queries can be handled. It also improves productivity for IT staff. Having one central server controls the whole network, which means less IT management time and fewer admins. One of the most important benefits of a centralized infrastructure is the issue of control. Due to the fact that the centralized server is on the premises of the company, system administrators will be able to monitor the entire company network and control traffic sent from all the remote sites. IT staff will also be able to modify and deny users based on the information configured on the policy decision point, PDP. Now, all this information is made available to the system administrators in the company domains. In big companies, there is always the need to keep a record of all documentation, transactions, files, and so on. Having a centralized database makes it easy for any employee with the appropriate clearance to access any of the company file or resources regardless of their geographical location. In other words, data and information can be easily shared across different departments, leading to better knowledge sharing and collaboration among employees. And then, of course, there's the issue of security. A centralized infrastructure is proven to be more secure than other infrastructures. In our user case diagram, we saw that the company had its own database, PAP cluster and PDP cluster. These are all vital parts of an enterprise network. The company can direct most of its funds relating to security measures to the centralized server location. With centralized security, companies also no longer have to deploy IT staff to individual network locations, freeing them to work on more strategic initiatives. Let's now look more closely at a decentralized infrastructure. The term decentralized clearly refers to items spread around with no central focus. In the case of a decentralized network infrastructure, the main controllers are spread around remote sites rather than having one centralized server. In the decentralized infrastructure, the workload is evenly distributed among all remote sites. A decentralized infrastructure is often referred to as distributed workload due to its nature. With a distributed workload, all the remote sites don't have to rely so heavily on the central server. The distributed workload approach has given rise to a lot of advancement in new and exciting technologies, such as edge computing and Internet of Things devices. This diagram illustrates the distribution of sharing of databases and servers within a remote site. Because users in a remote site have their dedicated resources, clearly this impacts the speed at which they can access them. Just as we used a user story to illustrate the structure of a centralized network, let's explore a similar user story to better understand decentralized infrastructure. The specification is slightly different for this user story. The system needs to be designed to support between 40,000 and 60,000 users with 3,000 queries simultaneously. In terms of resources, we're still looking at 1,000 hierarchical resources each, with multiple actions to be shared in communication between all connected users. The latency is the same as we had for our first scenario, but the infrastructure needs to be decentralized, where all 4 geographically locations would be sharing the workload of the entire company. So how would a decentralized infrastructure work in this scenario? The same terminology applies as per our previous diagram, but there are clearly significant differences. Here we can see the PDPs are distributed among the remote sites, and all of them share a common Entitlement Database repository and Policy Administration Point Cluster, PAP. Earlier, we said the Policy Decision Point, PDP, is a component used for making decisions based on the user's attributes from PEP. Here we see that both the PEP and PDP are on the remote side, which greatly speeds up the time it takes to resolve queries. So when looking at the benefits of a decentralized infrastructure, clearly on point is increased speed. The second benefit is having a decentralized database. This makes it easy for the system administrator in the remote site to configure their own PDPs to suit employees on the site in line with the PAP at the headquarters. This is mostly common in a secure workspace where sensitive data is transmitted within the site. Another key advantage is a distributed workload. In the case of the decentralized infrastructure, there is an even spread of workload across all the remote sites. Now, if we use the case study example, the companies in Asia, USA, and Europe will work independently without overloading the headquarters server for different queries. The remote site connects to the headquarters to update the policy administration points, which helps manage and control different policies and assess the impact of new policies on applications and services in the network. In our next lesson, we're going to have a look at cloud-based infrastructure and its benefits. Over the past 2 decades, the cloud computing model has changed the way that most enterprises manage their information technology systems and resources. Cloud computing has created the opportunity for organizations to access the data storage and computing capabilities that they require on an as-needed basis with a significantly reduced upfront cost. So let us move on to converged infrastructure. Converged infrastructure supports the use of grouped network devices into a single optimized system. The devices include the use of servers, data storage devices, and other networking equipment. The infrastructure uses virtualization. There's that term we said would pop up in this discussion to run cost-effective and highly automated systems. Now, in many big companies, a converged infrastructure is used to centralize the management of network resources. By implementing a virtualization system, the administrators are able to increase resource utilization and also drastically reduce costs in acquiring new hardware. Converging the group network device resources means they can be shared by multiple applications and managed in a collective manner using the policy administration points, PAPs, in the company network. Now, in this diagram, we can see how a converged infrastructure can be used for storage of data and information compared to a traditional architecture. You will see illustrations of storage in a hyper-converged and cloud-based infrastructure as well, but a little bit more on that just now. In most cases, companies usually purchase the entire converged infrastructure system rather than buying the hardware and software components independently from suppliers. This is pre-configured and pre-tested and ready for deployment. The converged infrastructure is often found in big data centers. So let's look at some of the benefits for using the converged infrastructure. Clearly, the first is its fast deployment. As mentioned, converged infrastructures usually come with all the pre-configured and pre-tested packaged components that are needed to deploy in the infrastructure, including network cabling, virtualized storage, and so on. These ready-to-roll infrastructures are examined by certified experts. The second benefit we need to mention is a reduction in deployment error and risk. Due to the fact that the converged infrastructures are tested before they're sold, the risk of error is greatly reduced. Companies acquiring the infrastructure are usually guaranteed a warranty on the packaged components, which means the company does not need to worry about day-to-day maintenance. The vendor supplying the converged system usually provides a single point of contact for maintenance and service issues. In the case where the packaged components are faulty, the vendor company is solely responsible for their repair and maintenance. And then there is the issue of cost. Because a converged infrastructure supports the use of virtualization, the company will be utilizing every hardware resources in the network, thereby saving funds on acquiring new hardware. Hyper-Converged Infrastructure. The last infrastructure we will be looking at in this lesson. It is basically an upgrade of the converged infrastructure. As can be seen in the diagram, in a hyper-converged infrastructure, multiple network devices such as server nodes and storage are combined to form a dedicated storage array hardware. Now, this infrastructure can be seen as a software-defined infrastructure, a unified system that combines all the elements of a traditional data center, which includes storage, network computation, networking, and event management. The integration of this infrastructure solution makes use of software and servers to replace built hardware. And in doing so, the infrastructure helps to reduce the complexity and increase scalability in the data center. Now let's have a look at some of the benefits of hyper-converged infrastructure. An obvious first one is its simple deployment. Virtualization software powers the hyper-converged infrastructure to fully utilize every hardware resource. Companies have the additional benefit of deploying virtual desktop infrastructure, VDI, even from a remote site while they are connected on the network. Another benefit is its flexibility. With a hyper-converged infrastructure, a business can use the virtual desktop infrastructure, VDI, for multiple data centers simultaneously. This also means businesses can adjust their policies even while the deployment process is being initialized. In terms of data redundancy, the data is replicated or mirrored and saved across different hard drives of different servers in the cluster within the company. Data replication is one of the best benefits of the hyper-converged infrastructure because in the event of a network failure, the data is backed up across multiple locations and can be easily replaced if needed. Another key benefit is the availability of data in a hyper-converged infrastructure. A hyper-converged infrastructure is mainly controlled by software in the virtual machine, running in the same cluster on a network. If one server hosting a virtual machine goes down, features like VMware High Availability restart the virtual machine on another server and assure the availability of those virtual machines. Applications and workloads can be easily and quickly migrated or replaced as all the infrastructure runs under one software control. Clearly, a hyper-converged infrastructure using virtualization is a real win. Companies could really gain by making use of this type of infrastructure. Basically, it simplifies management, consolidates resources, and reduces costs by combining computing, storage, and networking into a single system. The four major attributes of the hyper-converged infrastructure are storage virtualization, computing virtualization, networking virtualization, and advanced management, which includes automation and deployment. Hyper-converged infrastructure also supports rising cloud infrastructure. Now, with the virtualization being placed on the storage and server, businesses can simply install applications to run on the cloud and make them accessible to anyone on the internet. You will notice these similar attributes when we look at cloud infrastructure in our next lesson. I think it's time for us to take a short break. Did you know a business can clearly gain all sorts of advantages by using automation? Automation, using technology to make a process or procedure happen with minimal human assistance, is a fundamental part of managing hyperconvergence infrastructure. Before we end off this lesson, let's summarize by looking at a comparison of the four infrastructures: centralized, decentralized, converged, and hyperconverged. In terms of architecture, a centralized infrastructure is dependent on the central node or server. All the remote nodes or servers in the remote site will need to send their queries to the central node or server to access the policy administration points cluster at the headquarters. The architecture of the decentralized infrastructure has the entire infrastructure distributed among the remote sites. All of the PDPs share a common entitlement database repository with the PAP cluster, and this resides within the remote site. The architecture of the hyper-converged infrastructure has the entire infrastructure grouped into a single optimized system. These are done with the use of virtualization to get a cost-effective and highly automated system within the infrastructure. The architecture of the hyper-converged infrastructure is just an upgrade of the converged infrastructure, where there is a combination of multiple network devices, server nodes, and storage to form a dedicated storage array hardware within the infrastructure. In terms of cost, a centralized infrastructure requires the centralized node to be of very high specification because it will resolve a huge number of traffic from the remote site. Relatively expensive to implement. A decentralized infrastructure is relatively cost-effective to implement because the workload is all distributed between the headquarters to all the remote sites. A converged infrastructure is inexpensive to implement. If the hardware components are available, companies can optimize their environment by introducing virtualization to their infrastructure. A hyper-converged infrastructure is relatively inexpensive. The hyper-converged infrastructure utilizes every hardware by the use of virtualization. Then, if we look at security, a centralized infrastructure has its security focused more on the headquarters centralized server or nodes, which support other remote sites. In the case of the decentralized infrastructure, the company distributes its security across all sites within the company infrastructure. Converged infrastructures implement the use of vendor security, since the converged infrastructure system is pre-configured and pre-tested by the vendor. The vendor is responsible for securing the purchased infrastructure. With a hyper-converged infrastructure, security is adopted both in the cloud components and on-premises hardware and software within the infrastructure. What about failure tolerance? A centralized infrastructure has a low failure tolerance if one of the remote sites gets hacked. There is a good chance the whole company will not be affected because the main source of the resources is coming from the headquarters server or nodes. A decentralized infrastructure has a high failure tolerance since the remote site is sharing PDP, policy decision points, with their entitlement database repository on the remote site. If the remote site does get hacked, the company will lose a section of that database repository. Converged infrastructures have a low failure tolerance due to data replication in the system. Hyperconvergence infrastructures also have a low failure tolerance, a benefit of virtualization. If we look at company size, centralized infrastructures suit small to medium-sized companies. Decentralized infrastructure suits companies with a larger number of employees. Converged infrastructure suits any capacity of employees within the infrastructure, and hyperconverged infrastructure typically has been adopted by big businesses but suits any size of business. And finally, in terms of maintenance and scalability, a centralized infrastructure is low maintenance and is easily scalable because the centralized node or server needs to be optimized due to its workload. A decentralized infrastructure has higher maintenance because of the distributed server with a company's sites. All sites will need to be maintained because they have equal workload. But it is also easier to scale, as a business can simply add more machines to the network to add more compute power. Converged infrastructures require moderate maintenance, and it is easily scalable due to the benefit of virtualization. A hyperconverged infrastructure requires relatively low maintenance because the majority of its components are on the cloud, and scalability is a big plus. Upon completing this lesson, your assignment will be made available. This is an optional exercise for you to test your knowledge of the material so far. Assignments will happen once a week, so make sure you stay on top of your content to avoid being overwhelmed. You can access these in your profile under the My Courses page. Throughout this course, you will gain several practical skills alongside the much-needed theoretical knowledge and real-world examples. We will check in on these skills every few lessons, so let's just go through them quickly now. We are now well on our way to acquiring the required skills in terms of the fundamentals of networking. Today's lesson went a long way to covering what you need to know in terms of enterprise networks. Module 2 will be where we dive into the skills required for the awareness of common threats and vulnerability. Congratulations! You have completed Lesson 6. We hope you have enjoyed exploring enterprise network infrastructures with us. See you soon for Lesson 7.